Hello, hello, chat. Hello. Hello. Alright, well, back to the Arduino grind. Back to it. So, uh, here it is. Alright, there we go. Webcam is on. Alright, so, yesterday left off at electricity basics. So, hopefully I get through this and how long is Ohm's law? Ooh, they're all like an hour long, so I'll see if I can go through two, but I'm probably just gonna get through this one. All right, and it's how hot is it? It's 92 where I am, so it's really hot. So give me give me some time. All right, a second chat. Give me a second. All right, electricity basics. In this lesson, wait, hold on. Okay, cool. All right, I'm at chat. Let me lock in. Electricity basics. In this lesson, you will build your first circuit and use it to learn about where electricity comes from, how the components how the components in the circuit work together, and how electricity can be measured. Let me go this for now. Our modern society our modern society depends on electricity for just about everything. Communication, transportation, computing, lighting, and even clean food and water. But how do all these electrical devices work? In th in this lesson, you will build your first circuit and use it to learn about where electricity comes from, how the components in the circuit work together, and how electricity can be measured. Learning objectives recognize that electricity comes from charged particles, electrons, and that they move or flow along a path called a circuit. Distinguish between conductors and insulators. Investigate how the holes on breadboards are connected. Identify resistors. Identify resistors based on the number of colors on their bands. Identify the anode and cathode sides of LEDs and how LEDs allow charge to flow in one direction. Determine how electrical sources such as batteries provide voltage. Construct and experiment with a simple circuit. Distinguish between short circuits, open circuits, and closed circuits. Vocabulary. Anode. The electric the electrode the electrode or wire through which current enters a surface such as an LED, where current can flow only in one direction. So it enters the device, and cathode is where it exits the device. Breadboard used for prototyping electrical. Oh man, prototyping electronic circuits that allows for easy connection of electronic components. Circuit, a conductive path that electric current can flow through. Conductor, a material that allows electrons to easily pass through it. Conductance, a measure of how well a material allows electrons or electrical current to flow through it. Measures in Siemens? Siemens? Siemens current, a measure of the number of electrons or amount of charge passing through a point in a current in a specific time, measured in amperes, amps. Electron, a part of an atom that is negatively charged and can be passed from atom to atom, creating a flow of electricity. Insulator, a material that resists the flow of electrons. Ohm's law, I remember learning about this. A specific law that states that voltage is directly proportional to current. V equals IR. Prototype, an initial model of a device that can be used for testing modification from which the product is developed. Resistance, a measure of the opposition to the flow of electrons through a material, measured in ohms. Resistance is in ohms, okay. Resistor, an electronic. Yeah? Resistor, an electronic component that reduces the current in a circuit. Voltage, a measure of the difference in electrical energy between 2 points, measured in volts. I don't really like their spotlights. Their spotlights are like, I want it to be red. Is there a text to speech?
Dear team, I hope this
The attic groaned.
Newton's first law of motion.
Newton's first law of motion, also known as
He couldn't help but smile.
Newton's first law of motion.
He couldn't help but smile at.
Dear team, I hope this email finds you well. I wanted to
Dear team, I hope this email.
He couldn't help but smile.
Yeah, that's
I
Nancy.
can't believe we actually did it.
He couldn't help but smile as he watched.
Dear team, he couldn't help but smile as he watched the sun.
Dear team.
Dear team, I hope this email finds you well.
Newton's first law of motion, also known as the law of inertia.
He couldn't help but smile as he watched the sun rise over the horizon. It's golden.
This is
I
crazy.
can't believe we actually did it. The project is...
Dear team, I hope this email finds you well. I wanted to remind everyone that the deadline for
In recent years, scientists have made breakthroughs.
That works. Alright. Alright, chat. It's time to stay engaged, chat.
Invention Spotlight. Electricity. A popular story has it that American founding father Benjamin Franklin discovered electricity by attaching a key to a kite string and flying the kite in a lightning storm. As is often true, the real story is less cut and dry. In reality, Franklin didn't discover electricity, and the kite experiment was not a breakthrough but an afterthought. Todd Image. Franklin's greatest electrical insight was that electricity is a positive or negative charge that could move from place to place. He believed lightning was an example of such electrical movement. Intellectuals in France, including Thomas-François Dalibard, learned of Franklin's ideas and put them to the test with an experiment Franklin had imagined but never performed. There was no kite or key involved, though the idea was the same: cause a flow of electricity between storm clouds and a metal object on the ground. It worked. The experiment transferred electrical charge. Only after this experiment in France did Franklin perform the famous kite experiment, which duplicated the result. Great breakthroughs in science and invention are rarely the work of just one person. Sometimes collaborations produce innovations. Sometimes rivalries do, as is the case with Nikola Tesla and Thomas Edison, two men who played a big role in helping us tame electrical energy. Edison was already a famous inventor when Tesla, a Croatian immigrant, came to work for him in New York City. Edison's lab produced many creations, including the first commercially available light bulb. Edison and Tesla had very different personalities and approaches. Tesla's powerful imagination helped him visualize his creations, which he claimed sometimes came to him in a single flash of inspiration. In contrast, Edison was very methodical. He didn't care about theoretical ideas or understanding nature. He was driven to perform experiments that would lead to products he could sell. He often came up with ideas and left his staff to figure out the details. His team produced over 1,000 unsuccessful light bulbs before settling on a design that worked. Todd Image. The great rivalry between Edison and Tesla centered on the question of direct current versus alternating current. Edison promoted direct current as a way to bring electrical power into homes. DC flows in only one direction. However, DC power must be transmitted at very high voltages over long distances. These high voltages make it unsuitable for use in homes. Tesla favored alternating current. AC periodically switches its direction of flow back and forth, and the voltage can be stepped down with transformers, making it easier to transmit to homes. In the end, Edison lost the battle, and AC power is used throughout the world today. The invention of the transistor in 1947, another advance in harnessing electricity, was also the work of many researchers, though a team of 3 received a Nobel Prize for their major contribution. Previously, researchers had been searching for ways to control the flow of electrons in materials called semiconductors. Transistors are made of semiconductor material. Researchers tried using complex instruments to control electrical fields and move the electrons, but it turned out that a device that made direct contact with the semiconductor worked better. Thus, the point contact resistor or transistor was born. Engineers have never stopped making innovations to the transistor design. But the 1947 device was a crucial step. Transistors began the modern electronics revolution. They can be used to amplify signals, to build microchips, or as electronic switches. Transistors are used in computers, radios, televisions, phones, digital cameras, robots, and any other electronic device you could imagine. Todd Image. You will not be working with transistors directly as part of this course, but you will use microcontrollers, which have thousands of transistors inside.
Microcontrollers. Go to text-to-speech. Go to text-to-speech. Not an ad, but not bad. Pretty sure they have like a certain amount of words you could use. But that's better for getting through a invention spotlight. Man, guys, low-key, I'm so tired. Like, I feel like taking a nap, but man. If I don't stream now, I might not stream at all today. That's the thing. But I'm so tired. Oh man. Whatever. I'll get through this. So I got my Arduino project board. Okay. Time to actually get stuff. Oh yeah. How am I gonna film the video? Because I want to make a video for this. I have an idea, but let's see if this battery still works. This battery, like, I haven't touched it at all, but it's been years. It feels heavy. It feels like it should work. Okay, have that. And get my battery snap. I can. I should probably move the camera back, but like at this point, yeah, we're too far in, bro. Is everything I need for this in this bag? One yellow, one red, one green, one blue. Green, blue, brown. Yeah, it's these. And then I need one solid jumper wire course. So whatever these are. Move that to my left. Build the circuit. A circuit. Should I start recording now? Okay, let me open this battery. Super heavy duty zinc. That's what it says. Super heavy duty zinc. Zinc Homelander. Still haven't watched the latest season of The Boys. I want to watch Gen V first, though. The latest season of Gen V. I already watched the first season. I look, you have to refresh myself, though. Kind of forgot what happened. Okay. Battery acquired. Bam. Ooh. A circuit is a looped path that allows electricity to continuously flow. Usually a circuit has components in it such as a power source, switches, lights, motors, speakers, and other devices that use electricity to do something. In this activity, you will build a simple circuit that uses a battery to light up an LED. Before you start building a project, check out the where electricity comes. Where does electricity come from? Do this. Take 2 minutes and brainstorm all the devices you use on a day-to-day basis that use electricity. How many can you list? Is that in my... Is that in the workbook? Let's see. No. Complete this page after you have built the circuit from lesson 1. So I'm not there yet. Can name a few. My phone, lights, computer, oven, everything, at least all matter, is made up of tiny particles called atoms. Atoms are made up of even smaller particles called protons, electrons, and neutrons. The number of protons, electrons, and neutrons in an atom determines whether the atom is gold or silver, hydrogen or oxygen, or any of the 118 elements. Protons and neutrons are found in the nucleus, or center of the atom. Protons have a positive charge and neutrons have a neutral charge. Electrons, found on the outside edges of an atom, have a negative charge. Because electrons are smaller than protons and neutrons, and because they are on the outside edges of the atom, they can be passed from one atom to another. This moving charge is where electricity comes from. Proton, neutron, electron. For an atom, the number of protons is equal to the number of electrons. So the number of the equals the number of negative charges, making the total charge of the atom neutral. Sometimes electrons can break free from their atoms and move to other atoms. When an atom loses an electron, it has more protons than electrons, and the atom becomes positively charged. When an atom gains an electron, it has a negative charge. These negatively and positively charged atoms are called ions. On your left, you can see a negative ion, and on the right, you can see a positive ion. Transferred its electron. As electrons get passed around between ions, they can sometimes build up. The buildup of electrons creates electricity. When electrons build up, they want to flow to something that is positively charged to balance out. The flow is called discharge. Ooh. If that positively charged object is you, you might feel discharged. You might feel the discharge as a shock. Sometimes you can see a discharge as a spark between two objects. I've seen that before. Electrons want to move and flow. They can flow more easily through certain types of materials known as conductors. Metal is a good conductor of electricity, but some metals resist the flow of electrons. Materials electricity can flow through very easily are called insulators. Plastic is an example of an insulator. Do this. Look at some of the objects around you. Try to determine if they are good insulators or conductors without the objects in your kit. My mouse pad is probably a good insulator. This is made of a lot of metal, probably a good conductor. There are lots of different materials. Some are good insulators, some are good conductors. Using these different materials makes it easy to control the flow of electricity in a circuit. Okay, locate my project board. I have it right here. This board includes the Arduino and the circuit board. You will only use the breadboard side of this project for this activity. So I don't need this wire that I brought out. Coolio. A breadboard is a tool you could use to build electronical circuits. It gets its name from long ago when people used to build electronic circuits on actual pieces of wood that were used for cutting loaves of bread. Circuit breadboards have come a long way and become useful tools for creating electronic prototypes. Oh, so much fucking reading. Oh, I mean, so much reading. I don't mean to cuss. My bad. So much reading. Oh, I'm so tired. The breadboard you'll use is called a solderless breadboard. Each hole on the breadboard contains a metal connector that pinches wires. When wires are inserted to the holes, this keeps the wires from pulling out and gives a secure connections. Positive terminals. What does that even mean? In each horizontal row, yeah. Oh, so every one of these can, okay. Chat, I might low-key fall asleep on stream, guys. I might be cooked. I might be cooked, chat. It's just too hot, and I woke up so early today. Oh my goodness. Holy read.
Measuring electricity. Electricity can be thought of as the flow of electrons through a conductive path. One way to measure electricity is by electric current. The current in a river is the amount of water flowing past a certain point in the river over a certain time. In the same way, electric current is the number of electrons flowing through a certain section of a conductive path in a certain time.
Uh-oh. Did I lose? Do I have no more credits? Yeah.
Current is measured in amperes. Electricity can be thought of as the flow of
Electricity can be thought of as the flow of electrons through a conductive path.
One
That is
way to
fire.
measure electricity is by electric current. The current in a river is the amount of water flowing past a certain point in the river over a certain time. In the same way, electric current is the number of electrons flowing through a certain section of a conductive path in a certain time. Current is measured in amperes, or amps for short.
Amperes.
1 amp is equal to about 6,241,500,000,000,000 electrons flowing past a point in 1 second. Another common electrical measurement is voltage. Voltage is a difference in electrical energy between 2 points. It is a comparison of the number of electrons at one place versus another. One way you can think of voltage is as pressure that pushes electrons through a circuit. The more electrons, the more pressure and the more voltage. The unit for measuring voltage is the volt. A standard AA battery has a voltage of 1.5 volts between its two ends. A standard wall outlet has a voltage of about 120 volts in the United States and 220 volts in most European, Asian, and African countries. Resistance is another common electrical measurement. Resistance is just what it sounds like, a measure of how a material resists the flow of electrons. Good insulators such as plastic, rubber, and glass have very high resistance, slowing the flow of electrons. Good conductors such as metal have very low resistance and allow electrons to easily flow. Resistance is measured in ohms. The Greek symbol omega is often used to symbolize resistance in ohms. Conductance is a measure of how well a material allows electricity to flow through it. It is the opposite of resistance. If a material has a high conductance, it has a low resistance. Materials that have a high resistance have a low conductance. This is called an inverse relationship. Conductance is measured in Siemens.
Siemens. Chad, I low-key fell asleep. I'm... frick. I low-key might have to cut this short. There's so much stuff here. Okay. Okay, chat. This is what I'm gonna do. I'm gonna cut the stream short. I'm gonna go take a nap. And then... if I wake up in time, I'll stream. I'll do another stream. I'll do a part 2 of day 4. Because I'm so tired right now. Alright. Well, I guess it's not an ending soon. It's a be right back. I'll be right back, chat. I'll be right back. Alright. There's no one here, so I don't really have to say this, but like, I'm doing a part 2. So, see you guys.